I know some of you guys are surprised by the marks you're getting, right? It's not because it's just you got it, right? You can't get blood from a stone, right? There's no way you're getting 100% in this class without the abilities, okay? All of you have it. No, it's not. No, it's not, okay? Well, you guys are doing it. I'm like, that's the thing. If you could only get 40%, that's the best you could do, then that's all you'd be getting, okay? And, you know, it's somewhere along the lines you guys have said 50, 60 was good enough for you, and so you believe that, right? But it's not, you see it's obviously not true. And you know, it was good to see, my hope is every one of you gets 100 at least one test this year, right? Because it's a good feeling, and keeps you motivated for the next one. So like I said, this is totally different now, okay? We're not going to be graphing anything for the first time, okay? We're not going to be stat plot, we're not going to be L1, L2. This is just about organizing stuff. That's all it is. And one thing about math that really makes it complicated is its total efficiency. Sometimes 8 words can be done by one symbol. And if you don't know that one symbol, it's like, what are you talking about? Okay? If you've ever gone to another country that they totally do not speak your language, everything is like complicated and work. Okay? Just to order a pizza is work. Okay? It's just like trying to find the words, and the guy's looking at you like, what do you want? And you're like, oh, this is so frustrating. I want a pizza. How do I say I want a pizza to this guy? Right? You're pointing at pictures, you're doing whatever. He's like, okay, I get you want a pizza now, but what do you want on it? And you're like, oh man, I give up. So as you see with this, especially today, tons and tons of symbols. And you can see where we're going to want that study sheet, right? Because, hey, I'll see you in a week from now, over a week, and you'll see you may forget most of this stuff. Now, if you write it all out on the study sheet, you should be able to pull that out and do your quiz. Okay? So, right? And that study sheet is like, I am extremely impressed with how many students are doing study sheets, the quality of them. But where you're really going to see how awesome they are is in 2 months from now, when it's like, okay, guys, let's start studying for that diploma. And you've got all the symbols, you've got everything in one little nice spot, and we're doing diploma practice, right? And you're looking at all that. And the student that doesn't have it, okay, that's the student that's like flipping through their book, and they're asking me questions, and they're, what does this mean? I used to know what this symbol meant, now I don't even know what it means, right? They're asking people to borrow their study sheets, and they're making photocopies, and they're doing all these things, right? Because they didn't put that into place. Now, I never had you guys in grade 10, so this is the first time you've used them, right? But, you know, you got to get grade 10s on side, then they get it, and then grade 11 and 12, they got it into place. And I've got students that are using them in other subjects. When I first learned how to do this, it was for a social studies test, right? And a friend had taught me how he did it, and I'd never used them before, and I had awesome success on that social studies test, the best I've ever had. So I was sold right there, right? But I wasn't, taught them by a teacher or whatever. But actually, that's where I brought in study sheets. Was when I was in grade 7, social, a friend had taught me how to do them. And from then on, I've always used them. Used them all through university, all through high school, and was very successful at them, with them because of it, right? So now, we're just going to start off with something that hopefully you've seen this before. Okay, this is Canada, and the provinces and the territories. So we're going to talk about all the things that we need to know. So when we keep going, yes, Sam, thanks. So when we are doing these, and I say universal set, you're like, what's he talking about? What's a universal set? Okay? So a universal set, first thing, is a set of all the elements under consideration for a particular context. Okay? Now, it says list all of the elements of the universal set of Canadian provinces, territories, and so let's call it, and they call it C, obviously for Canada, right? So C equals, now here's your first thing that you need to know. Whenever we do sets, you don't do a round bracket like that. Okay? It's one of these, right? The little squiggle. So that is common. So it's like Yukon, Northwest Territories, always separated by commas. Nunavut, BC, Alberta, Saskatchewan. Okay. Now, if I put ... New Brunswick, do we get it? Now, if you did that on a test, though, I would mark it wrong. Okay? We're just going to be lazy today. It's been a long week. And then you finish with your squiggly bracket. So, the universal set is usually given by the letter U. Makes sense, hey? But in this case, it's Canadian provinces. Now, here's another thing that you need to, it's NC equals 13. Now, to translate that into English, what does that mean? NC equals 13. The number in the universal set C is 13, or the number of elements. Okay, so this is the number of elements in the set. Okay, so these are called sets, the things that are in those brackets. Okay, so you have your set. Then you have your subset. And your subset is a set whose elements all belong to another set. So one subset of C is the Western Provinces and Territories, W. Write W in set notation. Okay, so that's set notation. That's where our squiggle marks are. So W equals, squiggle, BC, Alberta, Saskatchewan, and Manitoba. Okay, and then we close it. Yeah, I get that. I've never heard of them called Western Territories, though. Okay, so how about just for the sake of argument, we cross that out. Okay. Believe me, these will always be well defined well. Now, this is your first really, really efficient, succinct nomenclature that says exactly what. Okay, so it's kind of like a horseshoe on its side. So it's like a long C. So that's W subset C. This means W, which is Western Provinces, is a subset of the Canadian provinces and territories. To put it in even more layman's terms, is a part of. Okay, subset is a part of. It's a subset of. Okay, is C a subset of W? No, it's not. C or is in is another thing to say. Now W is definitely in C. Is C in W? No, you could say some of them are. No, no, no. Are all of them? Are all the W's in C? Yes. Okay, all the W's are in C. All the Western provinces are in Canada. Okay? Now, so you could do it that way, or you could do this. Okay? That means the exact same thing. These two would be equivalent. One is the visual. Do you see how W is in C? C is the universal set, the entire everything, all the Canadian provinces and territories. W is the western provinces in that. Okay, so this is our very first symbol that we've learned. Well, actually, and this too, right? NC means the number in the universal set C. Okay, so a whole new word now, complement. Have you guys done compliments before? It's like, hey, nice haircut. Thank you, I appreciate it. But I think that's compliment with an I. So complement, and people your age are very, very good at this. Actually, all children are. And this is the opposite. So when your parents say clean your room, the complement of that is probably what it is right now. Okay? It is the complete opposite of that. So all elements of a universal set that do not belong to that subset. And that is written as W prime. Okay, do you see that little quote? W prime means the complement. So this means not W. That's what that means. So again, its efficiency makes it complicated. That little tick there means I want exactly not W. Okay? And sometimes opposites aren't always easy to think of. Okay, we know the opposite of up is down. Those are easy. Okay, what's the opposite of car? Motorcycle? Okay, see? Sometimes people are like, well, there is no up. Like, what would be, right? So you got to look at the context all the time. And if there was this many people walk to school, this many people drive to school, not driving would be walking. Okay, in that case, that's the complement. In that case, in that context. So you always need to know the context, because some things don't really have opposites all the time. Like lights. What's the complement of lights? Yeah, you can go dark, right? But, you know, if you don't know the context, don't go directly for what you think is the direct opposite all the time. Because maybe, like cleaning your room, you would say, oh, the opposite is not cleaning the room. But what if the context was this many people cleaned their room, and this many people cleaned the garage? Not cleaning your room would be cleaning the garage. Okay? So the context makes the opposite, not what we've always hot, cold, up, down, right? So we want to just think of, okay, what would not be that in this case? So in this case, what would not W be? So we've got Yukon, Northwest Territories, Ontario, Quebec, yeah, Nunavut. Okay, Newfoundland, PEI, Nova Scotia, New Brunswick. Okay, so let's just for our own, this is not Western provinces. Nova Scotia, NS. Okay, so can you start, like you guys, we've been doing this for like 4 units now. Can you start to picture what the quiz would look like, right? I'm going to want you to know, is this a subset of this? What's the complement of this, right? But I won't ask you what is the complement of this. I'll just say, give me C with the quote there, right? And some people will be like, what is this? What does that mean? What's that little tick mean, right? And that's the language. And do you think if you don't know the language, you can be successful on the test? Absolutely not. Okay? And if you do know the language, you're going, this thing was easy. Right? So, now Jasmine wrote the set of eastern provinces as this. East would be NL, Prince Edward, Nova Scotia, New Brunswick, Quebec, Ontario. Is E equal to the complement of W? Okay, that's a good question. Does E equal not W? So let's write that in English. Does E equal not W? Okay? No, does E equal not W? Like, does up equal not down? Yes? But not necessarily. E doesn't maybe, or up doesn't equal not down all the time because there's up, left, right I could have went. Yeah? E is not a subset of W. No. E is a subset of W? It would be a subset of C. Yeah, E is a subset of C. I would agree with that. E would be a subset of C. Okay, but look what E equals. You guys, we wrote them down. Look what E equals. Yeah, look what W equals. Are they the same? Look, are there territories in here? So are these equal? Somewhat? If you're saying somewhat, they'll never have that. A, yes, B, C, somewhat, never have it. And if they do, I know who's picking it, okay? If you're saying somewhat, that means no. These two are not the same. Why? Because it's missing. So the answer would be no. Because E is missing, let's be specific, the Yukon territories, Northwest territories, and the Nunavut. Okay, so now T stands for the territories of Canada. So T equals Yukon, Northwest Territories, and Nunavut. Alaska belongs to the Americans. They bought it for like $1 an acre or something like that. We're like, we don't want it.
Wasn't it owned by a Russian?
Yeah, they're like trying to sell it. We're like, yeah, we got enough. We're okay. Americans are like, yeah, that's a pretty good deal. I'll get it. They'll probably have gold up there and stuff. That's what. Okay, so here's the question. Is T a subset of C?
Yes.
So is T a subset of C? Yes. The next question is, it is a subset of W. Is T a subset of W? No, we crossed ours out. Okay, well look. There's W. Is T a subset of, is T in here? Look in here. Is there a T in here? There's no territories in here. Okay, remember what it means. When is T a subset? Is T in? I mean, if you really need to, is T in W? The answer is no. Now here's another question though. Is T a subset of not W? Okay, well look where not W is. Is T in here? Yes, okay. So when you hear subset, you can think in. Is T in there? Okay, and you need to look. Okay, Northwest Territories, Nunavut. Okay. Yukon, yeah. So is T, so this is T in, not W? And the answer is yes. Okay, now this is huge too, an empty set. An empty set is a set with no elements. Again, you might think, well, yeah, why are we taking time learning about something that doesn't exist? Well, they may just ask you, and here would be an example. The set of odd numbers divisible by 2. Give me an odd number divisible by 2. Yeah, and so divisible by 2, by definition, anything that's divisible by 2 is an even number. 2, 4, 6, 8, 10, 12, 14. 7.28, you're like, I can put that in my calculator, I can divide that by 2, but the definition to divisible by 2 means it divides nice. So is there any odd numbers that are divisible by 2? So the empty set is given like this. Your 2 squiggle marks, or it's like a 0 with a line like that, diagonal to it. Okay, so explain how you can represent Mexico as an empty set of C. Okay, now this is where you do not want to show off your lack of geography, okay? But Mexico's not in Canada. Okay, so don't fight for it, Gord. Okay, it's not. Okay, so then we would say M equals an empty set, or like this, or we can say M is an empty set of C, or M is an empty set of C. M standing for Mexico. Okay, so C would be any Canadian province. Is any not Canadian province Mexico? There would be an argument for that, yeah. Okay. What? He wants to know, this is what he asked. M is a subset of not C. Well, not C would be everything outside of Canada, right? So you would probably say yes on that one. Depends what mood I'm in. Yusuf, and it's you, I probably would. Yeah, I'll be honest. Okay, so key ideas. You can represent a set of elements by, so A would be, and remember, we've got the 2 brackets. Now you can do it using words as well, like A can be all integers greater than 0 and less than 6. You can use set notation. Remember how I've always taught you to read from the inside out. So they'll first define the variable, and then they put this line. So they say, I'm talking about x's, and then here is your inequality. Everything greater than 0 and less than 6, and x has to be integers. Now you can show how sets and their subsets are related using Venn diagrams. And again, this is a skill you need to learn. Some people are going to pick up on it extremely fast, and some people are going to struggle with it. It's how every unit works. Okay? None of you are getting every unit the same. And it depends on the person. Some can get them all, right? Some people can struggle with all of them. Some people be really good with these units, and right? But you'll have to decide, and you'll have to either pick up your game, or you're going to keep it the same, or whatever. Now, Venn diagrams are, again, a visual but really efficient way to be able to show data. And learning all about the little nuances, that's where the trick is. Now, sets are equal if they contain exactly the same elements. even if the elements are listed in different orders. Okay, that makes sense. Like if you have 3 marbles and I have 3 marbles and they're identical, and yours like, oh, yours are out of order. You're like, oh yeah, you're right, they are different. Okay, that's what? They're the same, right? Yours is just different order, right? So don't get all hung up on that. Hey, he's got a 1, 2, 3. I got a 3, 2, 1. Oh, that sucks. Thought we were gonna match up. No, you are matched. Okay, different order. Now, the sum of all the numbers of elements in a set and its complement is equal to the number of elements in the universal set. So that's what this says. The number of A plus the number of not A will equal the number in the universal. Now, it's kind of so simple that it's complicated, right? But if you have all the things, here's an entire set, and maybe they're numbers, and you're like, okay, so maybe it's numbers 1 through 10. Now, how many even numbers are there 1 through 10? Well, how many numbers are there 1 to 10? 10. Okay, so this is your universal, correct? So if I go the even plus the not even, I'm saying that's going to equal 10. So the number of evens, 2, 4, 6, 8, 10, there's 5 of them. And how many not even are there? 5 equals 10. Now, in this case, what are the not evens? What would I call them? Odds. Okay? So not even would be the odds. 1, 3, 5, 7, 9. Okay, so the even would be 2, 4, 6, 8, 10, and the not even would be 1, 3, 5, 7, 9. So that's where it's going to get where they can really play on you here. It's like, what are the complements of the even? They're not going to come out and just say, what are the odd numbers? Right? That would be too easy. They're going to say, what are the not evens? And you're going to have to go, like, what are they talking about? That must be the other ones. And then you'll write them down. And now, the number of A or B should equal the number of A plus the number of B. Now, these are if the sets are disjoint. So we're going to talk later about joint and disjoint. But the number of A or B, so there's 5 or 5 should equal the number of A would be 5 plus the number of B, which is 5. And by disjoint, we mean not overlapping. And I'll show you later what that means. Yeah, that's where we're going to have Venn diagrams. And sometimes you're going to have overlapping. Like, one, you'll say, okay, I want all the numbers, all the numbers between 1 and 10 and all the even numbers. They're 2 different sets. Do you see how they share some? Because all the numbers between 1 and 10 and all the even numbers from 1 to 10, they share. Okay? And then, again, this means the number of. That's what n's always going to mean, number. That will stay consistent. They're not going to use the number sign like I just did, but it always means number. And again, we're just learning a language here so we can all speak the same language. Now, Emma drew a Venn diagram, the diagram to the right. Okay? So she's got Fs. Now, do you see what C? C would be everything. Okay? C would be my universal. Now, in this case, C, you come over here, they'll have a legend. C stands for produce. F stands for fruit. So all of F is fruit. S, fruit you can eat without peeling. Now, do you see why S is in F? Because it's more specific, but it's still part of it. Okay? So, no need to peel. And V stands for vegetables. Okay. Now, when you look at the side, do we agree with this? Yeah, I think so. Now, is there another way that we could take these things and organize them? Was this the only way to organize these? What's another way you could organize these? Yeah. Yeah, exactly. So we'll let C equal produce. What's another name for C that we've learned already? No. If you had to name it something else, what could we name it? Everything. What's everything called? This is our universal set. Okay, so then let's go with O. O would be like orange produce. Okay, what would that be? Yeah. Orange and carrots. It'd be a shame if we forgot oranges. Okay. Let's go Y for yellow. So what's going there? So corn. Yeah, we'll pineapples. We got corn, bananas. Don't forget about the nanner. And then again, yeah, when they're ready for banana bread, they're not very yellow, but let's just. Okay, we can go green, G, right? So that's peas. Yeah, let's just say they are. It's been a long week. Let's just agree. Okay, beans. Let's go with. We'll even go with apples. You know, why not? Okay, and then B for brown. Never want to be the brown. That would be potatoes. Could have went red, I know, but let's just get through this. Okay. Now, why does it make sense? S, what does this mean? Is a subset. Is S a subset of F? Okay, so in other words, is S in F? Okay, if we look up here, S is in F. So yes, it is. I mean, you can see by looking, obviously, is S in C. Okay, and S is in C. Okay, now here's the new one. Disjoint sets. Now we're just looking at the above. Give me two sets that are disjoint, have nothing in common with each other. So F and V would be called disjoint. And what else? S and V. Right? Do you see that they, and F and S are definitely not disjoint. Right? F and S would be called joint sets or overlapping. Now here's the, and don't say it out. Like, I want you to think about it a bit, because if you say it out, then some people don't have a chance to think about it. Is the complement of F equal to V? Now just think about it. Don't say it out. Okay? And all I want you to do is write yes or no and why. Okay? You got lots of room there. If we need to cross it out, we'll cross it out. But I just want you to think about it first. Is F prime, that's called F prime, or the complement of F, equal to V? Okay, so putting up your hand, give me what you got. Yes or no, and why?
Yes, because all edible plants that are not fruits or vegetables.
Okay, so this means not fruit, correct? So yes, all non-fruits are vegetables in C. Now, we're not talking about the world here, we're not going to get all, but in our example that they gave us, all the non-fruits are vegetables. Okay? Now, NV, that stands for what? The number of vegetables. What does that equal? 5. Okay? NF. And NC is 10. Good. And if you're, just put a little, that's the number of elements in universal set. So, just like all the stuff that we've been doing this year, is it that hard? But if I just ask, if you haven't been here today, and I ask you for what's F prime, you're going to be like, I don't know. Like, you just wouldn't know, right? You'll either know or you don't. And that's why you want to get this stuff out of study sheet too, because by Monday, next Monday, you may forgot all of this, but you'll be able to look at your sheet and be able to do any quiz. Now, it says list all the elements of S prime. Now, first of all, what does S prime mean? No, let's be very specific. It is not what? Not fruit you eat without peeling, right? Okay, so what's another way to say that? Because we got so many negatives. We got 2 double negatives in there. What is it not fruit you eat without peeling?
Fruit that you need to peel.
Fruit you need to peel. Now, actually, that's not true. Yes?
Anything that's not apple or
Okay, no, that's true. Anything that's not apple, but anything in C that you need to peel to eat. It just doesn't have to be fruit. Right? So we would write it this, S prime equals oranges, pineapples, bananas, peas, corn, carrots, beans, potatoes. Now, I know what some people are going to say, but you don't have to peel carrots. You don't have to peel beans. But that's not what S prime stands for. It's all the stuff that is basically, like you just said, it's not apples or pears. This means, what is not apples or pears? In our set, right? We're not talking the whole world. Don't bring things in that aren't on this, right? So don't bring in sunflower seeds. They'll be like, where'd you get that from? Miss Trimble, that's not an apple or a pear. I go, yeah, but it's not in our universal set either. Okay? Okay, so this is where students usually start freaking out right about here. This is to draw an actual diagram, a Venn diagram of these 3 things below, E, F, and S. Now, E are the multiples of 8, F are the multiples of 4, and S is the multiples of 17. But they do qualify it first. You're only allowed to use this, the natural numbers from 1 to 40. So what I always do, I would have no chance of doing this without first figuring out what I have. So we are going to do our actual sets. Before I get going and drawing pictures, so my E is multiples of 8. So that's 8, 16. 1 is not a multiple of 8. 24, 32, and 40. Okay, we want to stop at 40 because that's all I've been given to work with. Now, the multiples of 4, 8, 12, 16, 20, 24, 28, 32, 36, 40. And the multiples of 17 are 17 and 34. Now, the entire box is our universal set, okay? So that's what's going to be all these numbers from 1 to 40 have to be in here. We have to put 1 to 40, but we've also been given other parameters. Now, do we see any sets in other sets? Like, is S in any of the other? Is S a subset of any of the other ones? No. Okay. Is F a subset of any of the other ones? E would be a subset of F, correct?
Yes.
Right? And it must be, like, you can say, F's a subset of E. Look, there's 8, and no. Is all of F in E? It has to be all. Is all of E in F? Yes, so you can say that. So let's just talk about E and F right now. So E, then one number doesn't make it, right? It has to be all of them. So E, what are the numbers for E? 8. So we're going to actually you just do a circle like this. 8, 16. Actually, you don't put commas. Sorry. 8, 16, 24, 32, and 40. Now E is in F, correct? So we want to make a bigger circle, and we're going to call that F. And in there I will put 4. 8's already taken up. 12, right? 16's already taken. 20 and 28 and 36. Now, do you see that the blue is in F, right? So E, this is still an element of F in here. See how it's inside? Okay, this is called a Venn diagram. So F includes these numbers. Does E include these numbers? No, it doesn't, okay? No, we're going to do one like that after, but if the entire thing is inside, like if you did this and say 4 is here, that means 4 is in both. But do you see how 8 is, there's nothing out of here, right? There's nothing in E that can't be represented in here, so you put it all in. So say you had a Venn diagram and it turned out like this, 5, 6, 3, and 4. You got nothing in here, then you actually end up going like this anyway, and you've got that. Okay? So if all that subset is in the other one, then you're not going to have the two. Yes? This one here, yeah? Yes. Yeah. Now this one, because it's common in the entire thing, it just goes all in. Now, are we done? Okay, what else do we need to represent? Okay, so would S be an E or would it be an F? It would be, what do we call it? Oh, that was beautiful. Okay. A little tear came to my eye there. Okay. You got S. What's in S? 17 and 34. Are we done? No, we're not. Because U stands for the universal set. So, is E in U? Is F in U? Gotta make sure I don't swear there. Is S in U? Okay? So, if you did not see all of this, So that's all you see. You've been given this diagram. What's the universal set? How would you know 1 to 40? If you were just given this picture, does this say the universal set is 1 to 40? Because I don't have 1 to 40. So we do have to put those in here. 1, 2, 3, 5, 6, 7, 9, 10, 11, 13. 8's in here already. Look. It's right there. 13. How about 14? 15, 18, 19. Okay. 21, 22, 23, 25, 26, 27, 29, 30, 31, 33, 35, running out of room here, 37, 38, and 39. Now that is every number in the universal set has been represented. And do you see how S is a subset of U? Does that make sense? E is a subset of U. E is a subset of F. F is a subset of U. Okay, so if I just said this one statement, could you finish it? F and S are disjoint, yes. What else are disjoint? E and S. Okay, so I have a question just like this, where there's a picture and then they're true and false. Is E a subset of F? True. In other words, is all of E, so let's just write it, that's our notes, right? Is all of E in F? Now the all is important. It's not some. Or Gord, what did you say? What was your word? Somewhat, yeah. Is somewhat most of E in F? That's not considered a subset. But if we can say all, and if there's one missing, don't pick it. Is F a subset of E? That's false. Is all of F in E? No. How about, is E a subset of E? That's like a philosophical discussion. Is all of E in E?
Yes.
It's actually no. Just kidding. Oh, this is good. Is F prime equal to the odd numbers from 1 to 40? Now I want you to write it down. See if you'd get this right on a multiple choice test. Or true, just true or false. It's true. Is F prime equal to the odd numbers from 1 to 40? And if you're saying it's not, give the example of why it fails. And if it works, you shouldn't be able to find an example. Okay, can everybody give me a not F that isn't an odd number?
30.
Okay, so this means not a, what is this? Not a what? Not a multiple of 4. So is not a multiple of 4, example would be 2, 3, but 3 is not a good example because even though it's true, is 3, but then that does fall into here. So you're like, oh crap, that's not. But this one makes it fail, right? So the answer to this would be false. If you can find one non-example, that's all it takes. You don't need 20. You don't need 3. You don't need 2. You need 1. Okay, and you could say, hey, not a multiple of 4 is 2. 2 is not an odd number, so that's false. Okay. Okay, in this example, the set of natural numbers from 41 to 50 is an empty set. That's true. Okay, I just want to do one more with you. This one's quick. Example 3. So let's call E equals the multiples, or I should use the multiples of 2 from 1 to 10. And F, so the multiples of 2 from 1 to 10, and F is integers from 1 to 4. Okay, so can you just take a minute? I'm just going to press pause here. I want you to come up with a Venn diagram that you think would represent. Now, first of all, I never go on to drawing until I've actually listed my numbers. That's 2, 4, 6, 8, 10. Okay? And then my integers would be 1, 2, 3, 4. Now, here's a question that I would ask, because see here how we put, like we said E is a subset of F, right? We agree with that. All of E is in F. Is this a true statement? Is F here a subset of E? But some of it is, right? But that doesn't matter. Okay? So this is no. So we just can't do a little bubble inside it. Does it share anything? Okay? So I would try and circle what they share. They share 2 and they share 4. And a little bit of 3 there. Yeah, just the top. Okay? So, like I can't put it totally inside, but so that's where we come up with this sort of situation, where we would put 2 and 4 there, and then if this was E and that's F, E would be 6, 8, and 10, and F would be 1 and 3. And do you see how F still includes 2 and 4, and E still has 2 and 4 in it? We haven't taken it out. It's just saying, hey, they share this. This is what I call the football. Now the football is what they share. Share the football. Oh, because I don't really, so that's good that you did, Gord. Okay? So, R, here's the other R, E, and F disjoint. See how they're jointed? So, no, they share 2 and 4. So, is E equal to F? Is not E equal to F? No, right? Because they share, like, because E, what's not E? E, not E is 1 and 3, correct? Is 1, 3 equal to F? No, okay? Because F equals 1, 3, 2, 4. So you always kind of want to write down what is not E, and I would write this, 1, 2, 3, 4, okay? Not E is 1, 3, and F is 1, 2, 3, 4, so they're not equal. Okay? Yes?
Is there a specific word for it if they only share some?
Football.
No,
Is that trademark?
Yes, it is. If you use it, I'd have to kill you. Okay, so page 5 to 7, this stuff goes fast. Get it done in class so you don't actually have to take anything home. Just remember, we did learn quite a bit today, believe it or not. We learned all the symbols and all the subset, disjoint, empty set, complement,